Thank you for downloading this podcast from The Reedy Clubby Show on Talk Radio 702 and 567 Cape Talk. For more, please go to 702.co.za or capetalk.co.za. Talk Radio 702 and 567 Cape Talk. The Naked Scientist.
And The Naked Scientist is brought to you by Grolsch Premium Lager. Choose interesting, not for sale to persons under the age of 18. Yeah, that's what it says. It says choose interesting. Don't send me emails about that. Chris, good morning.
Good morning.
Come on, sorry we're late this morning. Okay, so what mobile microbial cross-section, what's that about?
Well, there's this story which has come out this week from the University of Oregon, and scientists there have been wondering whether the gadget that now outnumbers the human race on Earth, and which officially, as they point out at the beginning of their paper, this is James Meadows and his colleagues, that there are more people on Earth with access to a mobile phone than a toilet. Can we use a mobile phone as a way to measure what's living on us and in us and what microorganisms we come into contact during our day-to-day business? And what they did was to say, well, we touch our phones on average 100 to 150 times per day. It makes it the most handled must-have gadget that most of us have in our pockets and in our handbags. So they got a group of 17 volunteers. They swabbed their index fingers and thumbs. They also swabbed the screens of their smartphones. And they extracted DNA from those swabs and used the DNA signatures to work out what bacteria were living on the people and then on the phones. And they found there's a really, really close match between people's hands, in other words, their microbiome, and their phone. And what this tells you is that things we contact, we obviously transfer bacteria onto. We knew that. But then what it is showing is that our phone can be used as a proxy measure of our microbiome. Why this is important is that when we go through an environment, whether we sit in a chair, work at a table, type on a computer keyboard, we're interacting with that environment and depositing bacteria and picking up bacteria. Now, those bacteria we pick up may not stay on our skin for very long, but they may stay on the phone for longer. We can therefore use the phone as a record of the kinds of bugs we've had interactions with during our day-to-day. And this means that we could, for instance, use this in the hospital. You could have a screening system so that when a doctor or nurse comes into hospital, they could have their phones screened, and you could then say, you're bringing into the hospital this nasty infection, go home or go and wash your hands. Or you could conversely swab them on the way home from the hospital and say, well, you're about to take home this rather nasty thing with you and give it to your family. Let's look at your infection control practices. And then there are wider implications. We can begin to marry up why certain people succumb to certain diseases. Perhaps they're having incidental contacts with certain classes of microorganisms. So they're saying this is a first step towards instituting this sort of screening and this better understanding of how we interact with the world around us. But it's a first step that's an important one.
That's really fascinating. But what's even more fascinating, and I wonder if you can explain this, is that the DNA analysis of the bugs recovered from the swabs in this experiment could accurately tie a phone to a person, more so even in women than men. I'm fascinated by that distinction.
Well, I thought you might be, but I was diplomatically not mentioning it on the grounds that it might lead to accusations of sexism if we speculate that the reason that the women's phones had a class or a cross-section of bacteria that more naturally or more accurately mirrored their own microbiome than the men's did, perhaps because the women were spending more time on the phone. I don't know. The other possibility is that women don't have pockets, and so they tend to carry their phone and therefore touch it more often than men do, so there's more likely to be a transfer of the microorganisms than the men, which is accounting for that slightly higher correspondence of the bacteria on the phone and on their hands.
Okay, our lines are open for you. What do you want to ask Chris on 021 446 0567 011 883 0702? Sean, we're coming to you in just a moment.
Talk Radio 702 and 567 Cape Talk. The Naked Scientist.
021 446 0567 011 883 0702. Sean in Soweto, hi.
Hi, I've got an interesting question. Chris, I listened to both times when you spoke about yawning and that you said it was linked to a primal instinct that we have in group setting. My son has autism, and for a long time I tried to get him to fall asleep. And I would yawn, but he never ever yawned back at me. Never. No, I've never observed it. And what I know is with autism, there's a little bit of one can't have empathy with people. One doesn't have empathy. And I was wondering if it's possible that yawning is also linked to being able to have empathy with people around you.
Hello, Sean. That's the most amazing question, and I'd never thought of that. And what a brilliant thought. I don't know the answer because I don't know if anyone's actually done the research on this. I suspect they have, because this whole contagious yawning idea stems from the idea that people are watching other people, and it sort of spreads like a ripple through a community as one person yawns and the other then yawns in sympathy in order to raise alertness. But you've got to have an awareness of the other person and want to be empathic with them to make that happen. So therefore it fits that someone who is diagnosed with autism and therefore may have a problem relating socially to what other people are doing, that may manifest. I'm going to go and take that away and ask some friends of mine, including Simon Barron-Cohen, if I can, who's an autism researcher in Cambridge, because I think that's a brilliant question, and I don't know the answer, and I don't want to give you some faffy answer. I want to see if there's proper evidence base on this. If I can't give it to you this week, I'll definitely have something for you next week. How about that?
All right, Sean, are you happy with that?
Can I quickly give you just one other thing I've thought of, and you can use it because I don't know lots about neurological science or whatever, but your primal instincts, aren't they lodged in the same places where your ability to have empathy is? I think it's a small part of the brain, and I don't want to mention but I think the muglu oblongata or something like that.
Well, you're thinking of part of the brain stem, the medulla oblongata, and whilst this does contain a lot of the circuits that are involved in regulating animal function, and what I mean by that is blood pressure control, next door to that is the bit that controls breathing, also some of your movements of your head and neck come out of that part of the brain stem, and the thing that keeps you alert and awake originates from there. But the whole point about relating to what other people are doing, that's much higher level brain processing. You've got to be able to decode faces or emotions. You've got to read other people's behaviour and put yourself in their shoes, asking yourself, if I was in their shoes, what would I do? Those sorts of things are much higher levels of brain activity, which go on further up towards the cerebral cortex rather than in the brainstem, which is more concerned with just keeping you breathing and keeping your blood pressure and heart beating.
Let's go to Francis in the Vaal. Hi.
Good morning, Reddy, and good morning, Chris and the listener. My question is very small and simple. I just I've been thinking, how come for all the existence of the world, the sun keeps on maintaining the heat? I think it's like melted lava, that it can never cool down. Like if a mountain erupted, the lava would get there. That red melted rock is like what is coming out from the sun. But with time, it solidifies to rocks. What happens that the sun only stays forever?
So the sun never cools down. That's what you're saying, Francis. Okay.
Hi,
Chris?
Francis. Well, the answer is the sun isn't cooling down. The sun's actually getting hotter. In the same way that as you light a fire and as the fire develops and burns more brightly, it puts out more heat because the chemical reactions are speeding up. The sun is a giant nuclear reactor. It's a big ball of gas and dust, largely dominated by hydrogen. It's fusing the hydrogen, in other words, causing hydrogen atoms to stick together, and they turn into a new element called helium, and the sum of 4 hydrogen atoms sticking together to make one helium atom means that there's some mass left over, and mass gets turned into energy because energy equals mass times c, the speed of light squared. That's Einstein's equation, E equals mc squared. So in order to balance the equation, you can turn mass into energy, and some of the energy that's streaming away from the sun is keeping us warm. It's radiating out into space, but it's also fueling the onward reaction of the sun. The sun has a very high temperature. The surface temperature is something like 6,000 degrees, and in the centre of the sun, it's something like 100 million degrees. So it's very, very hot. And so the sun is so hot and it's got a constant reaction going on, which is actually accelerating, and therefore it's getting hotter, not colder. And as a result, it won't solidify anytime soon. In fact, as the sun ages, it's currently about 5 billion years old. When it gets to about 10 billion years old, it will have puffed up into a red giant, which will be so big that the sun will stretch all the way from where it is now, the 100 million miles or so, to where the Earth and Mars are now. So we'll be completely engulfed by the sun in 5 or 6 billion years' time. Unfortunately, it will be curtains for us. We'll be fried to a crisp.
Thanks very much, Francis, for the question. There is a tweet here, and I see the Naked Scientists have retweeted it. A young man, this tweet says, a young man in Soweto suddenly started burning in flames, second-degree burns. Any scientific explanation?
Well, this is a phenomenon called spontaneous human combustion. People have studied it, but it's contentious, and they're not sure whether it's a real phenomenon, but people have come up with some suggestions to account for it. The various accounts that are given are of people, for no reason whatsoever, spontaneously and suddenly just abruptly bursting into flames. And in some cases, these people get completely consumed by fire, and sometimes there's nothing left. And one suggestion is that because people have got clothing on and you've got fat in your skin, once a process of burning starts, you can melt your own body fat, use your clothing as a wick, and that this then burns you and consumes you. But this begs the question, well, why would someone get a fire started in the first place? What would cause that to happen? One theory is that it's got something to do with the element phosphorus. There is a form of phosphorus called phosphine, which is where a phosphorus atom, P, gets stuck to 3 hydrogen atoms. So you have this molecule PH3, and this is a gas, and it spontaneously ignites when it mixes with oxygen. And in fact, you can see this happening if you go to marshland in the night time. You see this phenomenon of will-o'-the-wisp. You see these sudden flickers of light moving over marshland. And people used to think it was spooky ghosts and things. And in fact, what's probably happening is that at the bottom of the pond, you've got a lot of sediment with no oxygen in it. And the chemistry in that part of the marsh enables this phosphine gas to get made. It bubbles up to the surface, alongside things like methane gas, which is also being made in the same environment, mixes with oxygen, effectively detonates and lights the methane, and you get a bit of a whoosh, whoo, like that, and a bit of a flame. People have suggested that the bacteria that live in our guts, because there's an absence of oxygen inside our intestines, it's possible that some of the bugs in there could make some phosphine gas, and that therefore people effectively fart themselves on fire, because you deploy a fart which has got some phosphine in it. It lights in the presence of oxygen. When it gets into the outside world, this sets fire to your clothing, and the clothing then acts as a wick, soaks up the melting body fat, and you are consumed by fire. No one knows if it's true. Very speculative, but that's the best theory anyone's come up with.
I hope it's not true. I'm petrified. Oh, my word.
Yes, well, hold it in, Reedy.
Chris, let's go to, the story of the moment, in Bryanston.
Yes, okay. 2 days ago on the Tsoli Gwala show, there was some explanation about, there was a guy, I think it was
a psychologist who talked about Suarez, hey?
Yes, he said he had predicted that Suarez would do it. So I just wanted to know, is there any scientific explanation for that?
Okay.
Suarez is biting.
Luis Suarez always biting his opponents or teammates. In fact, it was a psychologist on this show who said that it's more a psychological thing, and the fact that he chooses to bite rather than kick someone is fascinating from a psychological point of view. And someone else was taking bets that Suarez is going to do it again. So, Chris, is there a scientific explanation?
Well, yes, it's human behaviour. You've got testosterone-charged, high-energy, high-stress environment where someone's running around in front of thousands of people. They're very pepped up. They desperately want to win, very competitive. You've got someone else who's got the same idea, but they're on the other side. And in the same way that wars break out and people fight, there's a war on the football field, and people just aggressively attack each other. And it seems to be worse in men, probably because of testosterone. Either way, it's unacceptable behaviour, and it's quite right that if you go around biting people, which transmits diseases and is thoroughly unacceptable, then you get a ban. So I'm very glad he got a ban. As to predicting that, well, you can predict this, because if someone has a track record of behaving in this sort of way, then it's more likely than not, if you say, well, I think this is going to happen, that if there's a World Cup round the corner, it's got a high odds of happening. And sure enough, it happened. So it's really basically coincidence that someone said it's going to happen, because someone else probably said it's not going to happen, but we're not going to talk about the person who said it's not going to happen because they were wrong. And so we have this sort of bias towards sort of what's called publication bias. People tend to have a preponderance to say things about positive things and repeat positive information that does appear to have some kind of positive outcome. People ignore things that don't fit their model or don't fit the mould. They don't talk about those. So as a result, we end up being I think, fixated on the coincidence and assuming it's got significance when it hasn't.
Okay, Rick in Morningside. Hi.
Hi, I have a thermodynamics question.
Carry on, please, Rick. You're live on air.
Let's say that I'm making tea and I open the refrigerator to get the milk out, pour the milk into the tea, and close the door of the refrigerator. Is that more thermodynamically efficient than taking the milk out, closing the door, putting the milk in, coming back and opening the door again and closing it again?
Hi, Rick. Well, it's a difficult one to answer, but just for the sort of clarification of the question, is it better to leave the fridge door open for a while you do the business with the milk, or should you open and close the fridge door?
Yeah.
The bottom line is that when you open the fridge door is sealed from the room and the fridge door is insulated because there's a very big thermal gradient difference in temperature between the inside of the fridge and the outside of the fridge. And when you open the door, the first thing that's going to happen is that the cold air inside the fridge, which is much denser than the warmer air in the room, is going to fall out of the fridge onto the floor and it's going to pull in behind it warmer air. So immediately the temperature inside your fridge is going to go up. Now, if your fridge is like my fridge, absolutely stuffed to the gunnels and there's virtually no space in there, then the amount of air that will fall out when you've got the door open is relatively small. And therefore, the amount of warm air that will go in is relatively small. The thing, therefore, that's determining most of the temperature of the inside of your fridge is going to be the stuff that's in there. That stuff is going to start picking up energy from the room as soon as you open the door. So the bottom line is that you're going to get very quickly the cold air falling out and warm air going in anyway, regardless of how long you leave the door open, pretty much. But the longer the door stays open, the longer the things in the fridge are going to start soaking up warm air, warm energy from the room, higher energy from the room by basically radiation of infrared from around the room and and contact with that warm air. So the bottom line is keep the door closed as much as possible, because actually that stops your food getting as much energy as it otherwise will from the room and going up in temperature.
We'll leave it there. Thank you very much, Chris. A pleasure chatting to you. We'll do so again next week.
Likewise. Thanks, everyone.
Bye-bye.
Great questions too. See you soon.
Indeed.
Bye-bye.
And The Naked Scientist was brought to you by Grolsch Premium Lager. Choose interesting, not for sale to persons under the age of 18.